Jambo Jambo. Habari sa asubuhi. Jina langu ni Denis Belgrado. I wish I can do everything in Swahili, but unfortunately, that's all. That's how far I can go. And I hope I did it right anyway. So, asante sana to Esri for giving us a chance to present. Today I'll be presenting the Trimble technology evolution. And for quick introduction, I guess that's my quick introduction over there. And I'll be talking a little bit about the brief history of Trimble, the core industry focus, and technology evolution. And later part of the presentation, I'll be showing some of the Trimble products that supports Esri ArcGIS environment. And if we have time at the end, maybe I could take some questions as well. So, it all started way back 1978 when the young Charlie Trimble had a great idea. And the idea was to quit his job from a prestigious Silicon Valley company and start his own in his garage. And I think some of his friends may have said to him, that is not a very good idea. But anyway, fast forward 30 years, so Charlie managed to build all of these GPS, and if you can see there on the images, he's built the Trimble 4000 SD. I think there was some other model before that that were actually really, really big. Okay, and later on the 1990s, he built the 4000 series, which became a little bit smaller, and then on the far corner, you see the Trimble 4800. That's basically all in one, or everything on the pole. And then from there, from that technology up to now, almost every year, or almost every product that we launch becoming smaller and smaller. Okay. Just to give you some idea of what kind of big product or big massive product that we used to build, here's one used in the Mount Everest expedition. I think it's really, really good picture here. So we, not us, not me, someone uses the yacht mounted tripod and 4000 ST receiver to track or to log data while going for the exhibition. Maybe this is something we should do for the Mount Kilimanjaro, right? Must be fun. Anyway, so that was the idea 30 years ago, and now Trimble, we have partners in 101 countries. We have customers in around 150 countries. We have offices in around 35 countries, and global research development in 16 countries, and sales support in almost all of the continent. And here in Tanzania, we have Optron for GIS, and I think another leader for survey. So, on the core industry focus, we have agriculture, we have heavy civil construction, building construction, geospatial, and this is what I'm going to be talking more about later on, and transportations and logistics. So basically with this core industry focus, we're trying to transform the way the world works, okay? And I'll show you how or why. So in the agriculture, we were just talking about this earlier. So we have all of these technologies, from a sensor that can be fitted into a harvesters or these machineries, or a guidance system, software that can do analysis, and even financial management, we have that. So from machine worker optimization up to all of these stages, we have all of these technologies within Trimble. Again, transforming the heavy civil construction from planning, designing, building, and operation. Again, within Trimble technologies, we have all of this from feasibility and planning, survey, design, estimation, earthworks, construction, maintenance and operation, all of this, all within Trimble. Another one is the, the building design and construction. The BIM, Building Information Management, we have that. And as you can see, one of the image on the far side, that's actually the building in Abu Dhabi that's leaning, well, optically leaning, but it's actually illusion. But basically, Trimble BIM software was used to manage that project. Again, we are transforming the transportation and logistics, making the driver safer on the road, consume less fossil fuel, and so on and so forth. And of course, with geospatial, we have all of these rugged sensors, data collection software, data processing software, data analysis, visualization. Again, we do have all of this technology in-house. So, as I mentioned, we have the full solution within Trimble. So we have the positioning in sensors, GPS, total station, IMUs, scanners, RFID, all of this technology, and we have the connectivity part, which we call enablers. So technologies that enables the software and hardware to talk to each other, to build a solution. We do have software that can do modeling. I don't know if you guys have heard about SketchUp. SketchUp? Fantastic. So yes, we do have SketchUp. Used to be Google. Then analytics, cloud software, we do have that as well. That's to form the full solution within Trimble. And again, looking at the Trimble GNSS receiver for geospatial application, so here we have the R8 receiver, the R10, R1, and R2. These are the smart antennas that can give you, we're talking about centimeter or even millimeter accuracy. We can go to that level. I mean, of course, there are some techniques on how to achieve that, but we do have those technologies to give you that much of accuracy if needed. On the handheld side for GIS, we do have the Geos 7 all-in-one. We do have the rugged tablet, and I will be talking later on about the latest receiver that we've introduced in the market. Don't be fooled with the size and with the cable and stuff like that. This is actually a game changer. Okay, so I'll be talking a little bit more about this at the end or later part of the presentation. So again, the bring your own devices craze, they call it. Everybody wants to use their own Android. Everybody wants to use their own iOS or iPhone, not just for personal use, but maybe for mapping or maybe for professional use. So of course, we at Trimble, we decided to build 3 products over here, the Trimble R1, Trimble R2, and again, that antenna that I'm showing you here, Trimble Catalyst, that allows you to use your Android device or iOS iPhone to get even to centimeter accuracy if needed. And of course, in terms of software, it can be Trimble own field software, or it could be Esri, Connector, or you can even build your own. We have SDKs available for that. So, I think I'm ahead of my slide. So here we have Trimble PenMap for Android. So that's basically a hybrid, if you you will, that's capable of performing survey task, data collection, as well as mapping GIS task or data collection. And again, that runs on Android device. And we do have the Trimble TerraFlex as well, that runs on the cloud, as well as on, in fact, on any platform. So TerraFlex can run on Android, iOS, Windows, except BlackBerry, I think. But nobody, I guess, uses BlackBerry. Anyway, so just to prove to you that with mobile phone, Android over here, and using Trimble R2 connected to a local VRS network for correction, and if you can see a centimeter accuracy, 1 centimeter accuracy. Who would have thought that, using Android devices, you would be able to get that much of accuracy from a split receiver. Of course, you need to use a data correction for that. But then again, Trimble R2 is still a little bit bigger for some GIS mapper. They want smaller device. So we created what we call Trimble R1. It's wireless, it's all-in-one, except that you have to connect your Android and iOS, iPhone using Bluetooth. It's not as accurate as R2 though, hence the name R1, right? So step down a little bit. But at any point of the world, you can get sub-meter accuracy if you want to. So Trimble has what we call Trimble RTX. That's a correction that's transmitted using satellite. So anywhere in the world, I think Antarctica even, maybe not, maybe I'm wrong, but almost the whole world, you can get correction. Of course, our customer, they always want some more. This is smaller, we want something more smaller. Trimble, customer is always right. Okay, let's make it. So we made one, not as small as R1 though, however, more clever than R1. So Trimble Catalyst is a smart antenna that can be connected directly to your mobile phone. For now, only Android, sorry iOS, but it will come soon, all right? So basically, that antenna sends the raw data into your mobile device, your Android, and essentially your Android device becomes the GPS receiver itself. So remember that big thing, the big box? That's basically residing in your mobile phone now. Okay? So the hardware GPS now becomes software GPS. And the clever part is, we can, or you can choose the accuracy that you want. Okay? So in a subscription model, you can subscribe depending on the use or depending on your project. For instance, you have a project this month that requires 1 centimeter accuracy. What you do, you buy the antenna, I think that was $350, and then you subscribe for the $350 precision accuracy for this month. Maybe you've made so much profit that next month you want to go for holiday, right? Then next month you don't subscribe for it. Next month after from the holiday, you have another project, but only requires 1 meter accuracy. Then you only subscribe 1 meter accuracy using the same antenna. Okay? So that's, I think, what with that model, we are allowing a lot of GIS people that wants to use accurate receiver, but doesn't really want to buy $20,000 receiver that they may not be using the whole time. So with that model, everybody can, I guess, spend $350 plus $40, right? So As I said, this is a game changer, and I think all of us, I love GIS, I'm from the GIS guys, GIS mapping, so I love this, and I think that is something that's going to be the next de facto. So I mentioned about the catalyst correction all over the world, and of course, we are covered. Okay? You go in the middle of the desert or wherever, you would get sub-meter accuracy. And if you want more, of course, you will have to connect to your own base station if you want more accuracy. Okay, so on the software part, we have solutions. I mean, Trimble and S3, we have really good relationship. And we built a S3 Trimble specific products. For instance, we have a free plugins for our Trimble Teradecks that you can, from within the S3 ArcGIS, send and receive data from the field, almost real time. The reason why it's almost real time because data has to go to the cloud, and then from the cloud goes to your local PC. And it can be stored directly to the geodatabase of S3. Okay? And again, the plugin is free of charge. Of course, everybody loves ArcPad. I love ArcPad. So we have also extension created for that. And basically what it is it's an extension that sits in the background. It doesn't have any interface at all. What it does is it mimics everything you do with ArcPad. You collect point in the background, it creates point. Do you draw the line or you draw the polygon in the background? It creates those data as well with GNSS observables. When you check in that data back into your ArcGIS, you can then post-process that data and you be able to get good or better accuracy. And here's what I'm talking about. So from within ArcGIS, you can do post-processing of your data from ArcPad. Okay? And even from our survey software called TBC or Trimble Business Center, we have now included a module that survey data, again, we're talking centimeter accuracy data, can be then written automatically into ArcGIS geodatabase environment seamlessly. And I guess this is the last one probably. Yes, it is the last one. So, mobile mapping, I don't know if you guys have seen that camera on the top of the screen. So that's what we call Trimble MX7. It's basically, it collects 360 degrees panorama images. You put that in your, on the roof of your car, you drive around, it collects data, and any point of the image that you collect, it could give you down to sub-meter accuracy. Better than sub-meter actually. So it has built-in IMU, inertial system, GPS and all that. And you just basically do your survey or mapping inside the office. So again, you can do that data collection from within the ArcGIS. So we do have plugins for that as well. So I think it's been a great ride for us since now on. And from that big bulky receiver, we are now down to a really tiny device like this. Okay? I don't know if I used all my time, but maybe if we have any time for questions, if you have, if not, that would be my part. Thank you. No questions? Yes, ma'am.
You said that your data could get transferred in near real time because obviously it has to go via satellite back. But can you work, say, for example, in a mine, can you work within the mine's own mesh network?
If there is a GPRS,
Yeah.
yes, yes, you can.
Then you can potentially give real time.
Absolutely, yes, you can. Yes.
Can you work with existing ground station networks accessible via mobile phone network? Like Rwanda has one.
Right, so you're talking about Encrypt clusters or Encrypt base station. Is that right? Absolutely, yes you can. Yes you can. So you can even make your own base station, you put it on the roof of your building, you transmit the correction via internet or Encrypt. So that can be accessible, yes you can. Yes sir.
I want to ask about accuracy. So the accuracy of the receiver depends on whether it's S1 or S2 antenna, and also the subscription.
So they, depending on the subscription, so let's say for instance if you're talking about the catalyst, right? So basically this is just the antenna collecting raw data. And what happens is the subscription unlocks that data that gives you that much of accuracy depending on your subscription. If you subscribe for, let's say, decimeter accuracy, so that code that we give you will only allow you to achieve decimeter accuracy.
So you can subscribe to either of the three using even the smaller antenna.
So the smaller antenna, the R1, sorry. Are you referring to this one here? Okay, so that, so this can only actually give you submeter. That's only submeter. If you want more accuracy, either R2 or the catalyst, this one here. Oh, sorry. Thank you for the question, by the way.